Okay, we're on polyatomic ions. So the good news is this, table 5.6, which is on page 2 of your chapter handout, you do not have to memorize this. Okay, and you don't have to memorize these here, which I've noted, which are things like acetate and hydroxide and ammonium. Because this periodic table has all of the polyatomic ions listed down here, except for the ones that I'm going to teach you the trick for. Okay? So the trick is we're going to be using something called the 3-4-4-3 trick. And the 3-4-4-3 trick is over here on this side of your periodic table, okay? When you have one of the non-metals above here with oxygen attached, the number of oxygens that are attached are indicated down here by these numbers. So if you have the 3-4-4-3 row, which I'll explain in a second, that means that your polyatomic ion is going to end in 8. If it's 2-3-3-2, it's going to end in Ight. If it's 1-2-2-1, it's going to end in Hypo Ight. And if it's 4-5-5-4, it's going to end in Per 8. Now there's a little typo on here, so what you're going to want to do is cross out the 8 or the Ight and make it an 8. So the 4-5-5-4 row should be Per 8. Okay? So let me explain a little bit here. So if you've got a polyatomic ion that ends in 8, like let's say I have the sulfate ion, okay? Sulfur is a nonmetal. When it ends in 8, it means there's oxygen attached. So what you want to do is you want to look at sulfur on the periodic table, and you're going to go down to the 8 row, which is this shaded 3-4-4-3 row. So it's SO4, that tells you how many oxygens are attached when it ends in 8. SO4, right below its group, and the charge on it is a -2, which is the charge above it. So the sulfate ion has a formula of SO4 -2. If I'm doing something like the chlorate ion, that sounds like it contains the nonmetal chlorine. It ends in 8, so it must have oxygen attached. So what you're going to do is you're going to look at the periodic table where chlorine is. You're going to go below its group to the 3-4-4-3 row, because that's the shaded row for anything ending in 8. So ClO3, that's how many oxygens are attached to the chlorine, and the charge is going to be a -1, because that's the charge above its group. So ClO3 -1 is the formula for the chlorate ion. Okay? So if we're doing something like carbonate, obviously contains carbon, it ends in 8, oxygen must be attached to carbon. So you would go, okay, carbon's right here. I'm going to come down to the 8 row, which is the shaded row. So it's CO3, and the charge on it would be a -2. Okay? If I'm doing phosphate, phosphate would be PO4, -3. Or iodate would be IO3, -1. Or bromate, BrO3, -1. The only 8 that this doesn't work for is nitrate. So when nitrogen has oxygen attached, you see how there's a circle around nitrogen, and there's an arrow pointing over here to group 7A. That means if oxygen is attached, if and only if oxygen is attached to nitrogen, do you go over to group 7A and you follow that numbering system. So if we're looking at nitrate, nitrate would be NO3 -1. If you've just got nitrogen alone with no oxygen attached, then it usually has a -3 charge and you don't go anywhere. This is only if oxygen is attached. So you may want to make a little note along this little arrow that if it's an 8 or an Ight, are you going over to group 7A? Okay? Okay, now let's move on to the Ights. So if I have something like the sulfite ion, okay, then what that means is you're going to go to the 2-3-3-2 row, and you're going to come up to sulfur, and it's got 3 oxygens attached, and the charge is -2. So sulfate ion is SO3 -2. If I'm doing the chlorite ion, okay, then that means I have one less oxygen than the 8. So that's why I go to the 2, 3, 3, 2 row. So it's ClO2 -1. So the 8s are the 3, 4, 4, 3 row. Those are the number of oxygens attached to that non-metal above it. And the ites are the 2, 3, 3, 2 row. They lost one oxygen from the 8s, and the charges remained the same. Again, if you have something like nitrite, which has oxygen attached to nitrogen, then you would come over here to group 7A, and you would go down. NO2 -1 is the nitrite ion. Okay? Okay, now, there is also something called a Hypo Ight Ion. So if I'm doing something like the Hypo Sulfite Ion, okay, that means it has one less oxygen than the ites. So I'm going to go to the 1, 2, 2, 1 row. So I'm going to come over to sulfur, and I'm going to come down to the 1, 2, 2, 1 row. So SO2 -2 would be the Hypo Sulfite Ion, which looks like that. Okay? If I'm doing something called a Per8 ion, then that means I added an oxygen to the 8 row. So now I'm looking at the 4, 5, 5, 4 row. So if we're doing persulfate, you would come over here to sulfur, and you would go down to the 4, 5, 5, 4 row. So SO5 -2 is the formula for the persulfate ion. Okay? So it look like that. Okay, so that's how you use the 3, 4, 4, 3 trick for figuring out some of the polyatomic ions, okay? Now, I'm going to make a couple of notes on the periodic table in case you want to use the trick, but you don't really have to. So, chromate, which is down here on the bottom, this CrO4 -2, if you want to, you could write Cr right there above oxygen because it follows that numbering system for the 8. So CrO4 -2, it follows that numbering system if you want to use it. The other one is permanganate. Permanganate is listed down here at the bottom. It's an MnO4 -1. Permanganate follows group 7A if you want to write an Mn above it. A lot of people confuse things though when they do that, so it's up to you whether you want to do that or not. You don't have to because it's already listed at the bottom. Okay? Alright, now, one more thing is sometimes they put hydrogen in front of a polyatomic ion. So what I'm going to do here is teach you how to write the formulas for polyatomic ions that contain hydrogen in front of them. Okay, so if I give you something called the hydrogen phosphate ion, okay, that just means it has hydrogen in front of phosphate. Sometimes when there's hydrogen in front of a polyatomic ion, they replace the hydrogen with a bi, and they put it in front of the name of the ion, and it's perfectly acceptable. So biphosphate is the same thing as hydrogen phosphate. Either one of them are acceptable. You may use either one, okay? So if I'm writing the hydrogen phosphate ion formula, what I'm first going to do is write down the symbol for hydrogen, its usual charge, which is H+1. If I'm looking for the symbol for the phosphate ion, remember, Sounds like phosphorus, which is a non-metal. It ends in 8. So I'm using the 3-4-4-3 trick. This is PO4 -3. So I write down PO4 -3 for the phosphate ion. What you're going to do here is add the +1 and the -3 in those charges. Okay? When you add a +1 and a -3, you get a -2. So this becomes HPO4 -2, and you just bring together the symbols. I'll do another example for you. Let's take a look at the hydrogen sulfate ion. Okay, this is also known as the bisulfate ion. So, we're going to write down H+1. Then we're going to write down the formula for the sulfate ion. Contains sulfur, ends in an 8. We're using the 3-4-4-3 trick. So this is SO4 -2. I'm going to take the +1 and the -2 in the charges, and I'm going to add them together. A +1 and a -2 give me a -1. So this is going to be HSO4 -1 for the formula. Okay? Okay, now let's take a look at student exercise number 4. Write the name of each of the following polyatomic oxyanions. The first one is CO3 -2. That's carbon with oxygen attached. You're going to go look at the 3-4-4-3 trick. So come over here. This is CO3. That's carbonate. Okay? So this is the carbonate ion. And anytime you have an ion, anything with a charge in the upper right-hand corner, you have to write ion after the name. Okay? All right, for the next one, CrO4 -2. Okay, so this is one of the polyatomic ions that is listed down at the bottom of your periodic table down here. Okay, so this is the chromate ion. So we're just going to write chromate ion. Okay, the next one, ClO2 -1. Okay, so we're going to take a look at chlorine because it has oxygen attached to it. ClO2 is hypochlorite. So this is the hypochlorite ion. Okay? And then the last one is HSO4 -1. This is one that we did in the example up above. So this is the hydrogen sulfate ion, also known as the bisulfate ion. Either one is completely acceptable. Okay? Now, let's make a quick note. Anytime you are writing the formula for a polyatomic ion, we never write the number 1 as a subscript. And we talked about this a while ago when we were doing something different in a different chapter. So I want to give you an example of something like the hypochlorite ion. Okay? The hypochlorite ion, that's chlorine with oxygen attached because it has a hypo in the beginning and an ite at the end. So you're going to come over here to Cl. Okay? Hypochlorite, that's going to be this row, ClO, and there's a 1, has a -1 charge. You never write it with the number 1 as a subscript, okay? That is just omitted. This is correct, okay? So don't ever write the number 1 as a subscript. It's a rule. And I think you are ready to go on and do the Naming Polyatomic Ions worksheet, which is 55 points, and it looks like this. There's no back, and you're going to be applying everything that I just taught.